Okay, I want to go over some basics of solutions. So mainly what a solution is and some general terminology associated with solutions. So a solution is a homogeneous mixture. It always consists of at least two things. Now we'll keep it simple and look at only solutions that have two components at the moment, but they can contain more than two things. But it is a homogeneous mixture, meaning it appears uniform throughout. And if you took small samples of a solution, they all will have the same proportions of the substances in that mixture as the original solution. So when we talk about a solution and focus on the things that make up that mixture, we'll classify things as solutes and other things as solvents. Okay, and so if we're looking at just a two-component solution, you have a solute and a solvent. If you had more components, you'd just have multiple solutes. There's always just one solvent. In general cases, I guess there could be something very complex where they might want to consider more than one solvent, but we're going to keep it simple for now. One solute, one solvent. Okay, and the difference between a solute and a solvent has to do with how they're mixing, essentially. So the solute is the thing that is dissolved. And when we use that term dissolved, that means that that substance is completely surrounded by another substance. Okay, so when we dissolve something in something else, those things that are being dissolved, whatever particles they are, each individual one is surrounded by what we call the solvent molecules. Okay, so the solvent is the thing that is doing the dissolving. So it's doing the surrounding. Now, most often, the thing we classify as the solute is going to be the thing that is in the lesser quantity. That's going to be the thing that is then surrounded because there's less of it. And so you could also call that the minority component, whereas the solvent is the one that is usually in the greater amount, and so that would be the majority component. Okay, so if you have a solution, then you're going to have lots of solvent, within that solution, and then small little solute particles that are essentially like floating around in there, completely surrounded by the solvent. Now that picture I have there, the different colors are used to just show just a general idea of the relationship between solute and solvent. Keep in mind, you wouldn't be able to see these solute particles floating around, and otherwise we'd be talking about a heterogeneous mixture, which we're not. We're focused on homogeneous mixtures, which we call solutions. So if we were thinking about ionic compounds would actually break up into ions, whereas covalent compounds, if they're the solute, they just get surrounded as they are. Most often when we're dealing with solutions, we are dealing with solutions of ionic compounds, and most often those ionic compounds are dissolved in water. But you can have lots of types of solutions. You can have different things as solvents. You can have, ionic compounds or covalent compounds or acids in solution as solutes. Okay, here's a couple more diagrams showing you what's going on in a solution. So if I were to dissolve, say, hydrogen sulfide, so H2S, into water, that creates an acid solution called hydrosulfuric acid. And within that solution, since it is a weak acid, it actually, the majority of what's in there, you'll have lots of H2S molecules individually surrounded by water. Some of it will ionize, and so in that diagram on the left, it doesn't show you any ionized H2S, but a very small proportion of it would. And you'd also have some H plus ions that are surrounded by water, and you'd have some S2 minus ions that are surrounded by water. But since the proportion's so low on this scale, it's not showing it. Now, the other picture is showing you if you had a solution of copper 2 sulfate. So copper 2 sulfate is an ionic compound. It is soluble. And so when it is placed in water, the copper 2 ions would release from the sulfate ions. And you would have the individual copper 2 ions surrounded by water, and you'd have the individual sulfate ions surrounded by water. And so that's the general idea of what is a solution, what's happening when you put something into another something and it dissolves and creates a homogeneous mixture or a solution. Now, there's lots of kind of general terminology associated with solutions that we can use. Instead of talking about quantitative stuff numerically, we can talk about it in more general sense, okay? So first off, let's talk about some terms related to solution concentration. So concentration, I'll go a little more in depth in some other videos looking at actual numbers of concentrations. But for now, let's talk about kind of the terminology associated. If we wanted to discuss the concentration without putting a number to it, we could talk about solutions and call them either dilute or concentrated solutions. So dilute is just telling us that there's only a small amount of solute relative to the solvent, whereas concentrated is saying that it has a large amount of solute compared to the solvent. Okay, and so these terms are just general terms. They're not telling you an exact amount. We can quantify concentrations numerically, which is telling you exactly what's in there. But this is just some generic terminology. So to give you a sense of, do you have a lot of solute or a little solute? Okay, so that's kind of common to talk about it in a general sense. There's a couple more terms that come up that we'll talk about in just a minute, but I did want to show you this picture. So with dilute and concentrated solutions, just to see it more on a molecular level, and then what it would look like kind of macroscopically. So if you had a solution of copper 2 sulfate, if it was a concentrated solution, that means you have a lot of solute particles in a given solvent. Okay, so the first picture on the left is showing lots and lots of those ions in this small space, right? But then the second picture, you notice there's fewer ions in that same kind of volume that's being shown. Whereas the third picture, there's even less, okay? So when you look at those pictures, on the very left is the most concentrated solution, on the very right is the most dilute solution out of those, okay? Now, this I wouldn't say is the best picture. You can't tell the color change quite as much as I'd like, but if you look closely, you should see the concentrated solution is a darker blue, and it lightens as you go towards the right. And that's because the copper 2 ions produce kind of a blue solution. So the more of them that are present, the darker the blue the solution. And so it becomes kind of more and more light as it's more and more dilute. So there's less copper 2 ions floating around. That's kind of a common one, but any solution that is kind of colored, if you add more solvent to dilute it, it's going to lighten and it's going to look more and more clear, essentially. Now, a couple other terms. Stock solution is another kind of generic term that tells you something about a solution's concentration. A stock solution, that's going to refer to a concentrated solution, one that we actually use to prepare dilute solutions, because it actually is a lot more effective to store solutions in concentrated form. Okay, it's more efficient, I should say, because it takes up less space. Okay, because the solute particles aren't going to take up very much space. It's the solvent that's taking up all the space. And if we're talking about an aqueous solution, which we often are, all you have to do to get a dilute solution is add some water, okay? Which we can just turn on the faucet and get some water and add some water to dilute it. And so stock solution is a concentrated solution we use to prepare whatever dilute solution we need, okay? And then another kind of general term that refers to concentration is standard solution. Okay. And if we call something a standard solution, that's one that we know the concentration vary at. So it's been standardized. And then the reason that that's important is because sometimes we use one solution to determine the concentration of another by performing a titration, which specifically is a reaction in solution. And we quantify things and we can then relate the concentrations of the solutions. And the more accurately we know one, the more accurately we can determine the other. Okay, so that term comes up when you're dealing with titrations, which we'll talk about at some point. Okay, now there's one other set of terms that I want to talk about with respect to solutions, and that is related to what we would call solution saturation, which kind of has to do with concentration of the solution. We're just looking at it in a different perspective, okay? So solution saturation relates more to how much solute you have in there relative to the maximum. Because you can add solute to a solvent and initially it may dissolve, but as you continue adding solute, eventually there's just going to be too much and there's not enough solvent to surround the solute particles, okay? Or it no longer is energetically favorable to continue to surround those solute particles. And that kind of limit of how much can dissolve is related to saturation, okay? So we have kind of three terms related to saturation. We can have an unsaturated solution, a saturated solution, and a supersaturated solution. So the difference between these things is how much solute is in that solution relative to the maximum possible. And so unsaturated means there's less than the maximum amount of solute dissolved. That should make sense. Saturated means it contains the maximum amount of solute dissolved. Okay. I have a typo there. I apologize. Let me fix that. So it's not solvent. It should say solute dissolved. Solvent doesn't dissolve. The solvent dissolves the solute. And then, let's see, the supersaturated solution, that is something that contains more than the maximum amount of solute dissolved. Now that seems kind of odd, because when you have a maximum, that should be the actual maximum. Like you can't go past that. Well, a supersaturated solution is an unusual scenario, and it's not something that happens on its own. It's something that you have to kind of trick the system into doing, okay? So you have to trick it into dissolving more than it wants to, essentially. And so that's a little trickier. And so what happens is the only way you can create a supersaturated solution is typically you increase the temperature of your solvent, okay? You increase it higher than what your final solution is supposed to be at, and then you dissolve extra stuff. And then you carefully cool it down. And that's because usually at a higher temperature, the solution has a higher solubility, where the solute, has a higher solubility, higher saturation limit for that particular solute. So if you increase the temperature, you can get more to dissolve. And then if you very carefully cool it down, then what happens is that stuff that's already dissolved, as long as you don't bother it, it stays put. But if you like bumped the flask, or you started stirring it, or you stuck something in it, then it'll start to precipitate out, and so the solid will come back out. So basically, an unsaturated solution, since it has less than the maximum amount dissolved, you could dissolve more in it. Okay, if you added more, more would dissolve. Whereas if it's already saturated, if you added more solute, it would just stay solid. It would just sink to the bottom. If you had a supersaturated solution, any kind of disturbance would cause precipitation. And so the excess solute would come out of solution, it would no longer be dissolved. So that would include if you tried to add more solid. And so this is how like they make rock candy. Seeing that. Got a picture here that shows if we have, this, what looks like, we've got this homogeneous solution to start with. It may look like water, but it's a homogeneous solution. And so it's at a high temperature and it was at a high temperature and they dissolved a lot of excess salt in there and then cooled it down. And as long as they don't bother it, it's fine. But then what they've done is they add what they call seed crystal. And so they add just a little crystal of the salt to that. And what happens is you start seeing it crystallize out. And so you can see in the second picture and in the third, there's even more. And so that's all that excess solute crystallizing out of that solution. Okay. So that's just some basic terminology associated with solutions. There's, I'm sure, more stuff that'll come up, but that's a good start to kind of understand what people are talking about when we're talking about solutions.